Section 2.3, Theorems of Limits. The theorem of limits says something like this. The limit of two functions added together is equal to the sum of limits of each individual function. You calculate each limit first, and then you add the total together. And the same with subtraction, multiplication, and division. Division with the exception that the denominator had better not be 0, otherwise it doesn't work. But everything works like this. In other words, it works very nicely and intuitively. Now, to show how this works, what that effectively means, all the theorems mean for limits, is that you can simply plug a value in there. For example, look at this very easy problem. What happens to the limit of this expression as x approaches 0? Well, if x is very, very close to 0, then this is almost non-existent. So you got only about 1 left. The square root of 1 is simply 1. And that's the answer to the limit. In general, you just plug in whatever value you're supposed to approach to and calculate the value of the expression, and that's the result of your limit. However, that trick might not work if you have a situation like this. For example, you have x is approaching -2, but the problem is that that makes the denominator 0. And we have mentioned that the division only works if the denominator is not 0. Well, what if it is? Well, sometimes you can still get it to come out. In this case, for example, we will factor this thing. So if you factor it, you have x plus 2, x minus 2. And then on the top, you have, say, you have x and x squared. And you have to factor this thing out. Since we have a plus 2, we'll put a 2 here to multiply x squared. And then, of course, that gives you -1. And that, if you work it out, is exactly this thing, which means this happens to be very easy to factor. In any case, so we come up with this stuff, and this is, we have to take the limit of this thing. And remember, as long as when x is approaching -2, when you actually plug in x -2, you cannot factor these things out because they become 0. You cannot factor out zeros. However, being that x is only close to -2, close but not there, you can factor it out because x is not actually -2. We're just taking the limit. So then what you get then is this value right here. Now we will let x be -2. And what happens when x get all the way to -2 is very close, by the way, is you just calculate this thing out. That will be 3 on top, and then -4 on the bottom, and that is our answer. So most limit problems are quite easy except for this kind, which then you have to factor and get rid of the common factor, remembering because x is not exactly -2, it is merely close. And you can always cancel out the factors, and then you will get you a denominator that isn't 0. Now, let's look at a harder question here. This is, you are supposed to come up with a function. You're not given one. Come up with a function and a certain integer n that's bigger than 0, such that the limit of the function of x to the power n is going to be something, okay? However, the limit of the function itself does not exist. Now, if this doesn't exist, why would that exist? So then you have to come up with some weird thing after you tinker with it for a while, and you eventually will come up with something like this. This is, well, at least this is what I came up with after some thinking. You will define f like this, okay? Fx equal to square root of x when x is bigger than 0. Notice bigger, not equal to. And then we'll call it something else like -1 when x is less than or equal to 0. In this case, f is defined on the entire real line, but as you can see, there is a jump there between at S0, it is -1, and after that, it jumps up to a positive number. So it's -1 all the way, and then jumps to something else. All right, so f is well defined, and then we'll choose n equal to 2. So then what is f of x squared? F of x squared, no matter what value x is going to be absolute value of x when x is not equal to 0, okay? And it equals to -1 when x equal to 0. Okay, so this thing is pretty good. It has a defined function, except that there's one point that it jumped, actually it dropped to -1. So then what is the limit? The limit of fx squared as x goes to 0, the limit as of absolute value, now the limit exists, because before, when you take the limit, the two sides go to different places. That goes to 0, that goes to -1. But now, as x will go to 0, x got squared. So both sides will approach 0. So both sides will follow that equation, and so then the limit equal to 0, and it does exist. And that concludes our explanation of this weird little problem.